It's time for our last example in Chapter 5. This is a story problem that I wanted to show you because it uses base E instead of base B like we've been doing through the rest of the chapter. So the table below shows that people with more education are less likely to be unemployed. So this was Census Bureau information from I think around 2006 or so. But anyway, so here's what it happens. So these are the grades that you had completed or got a degree from. So let's say you have a high school education. If you have your high school diploma, then you've completed about 12 years of schooling. If you have some college, then that's 13. But if you actually finish your associate's degree, that counts as 14, even though actually most associate's degrees take longer than 2 years to obtain, usually because people are working on full-time jobs and stuff at the time. Bachelor's degree is equivalent of 16 years and so on. Okay, and then these are the corresponding unemployment rates. So you can see that people with doctoral degrees only have an unemployment rate of about 1.1%. But people that have high school, just high school, no college at all, have an unemployment rate of about 4.2%. So the more educated you are, in general, the lower your unemployment rate is. Now, this was before the big economic downturn, but nevertheless, this trend still is borne out even now. It's just that all the numbers are higher, right? This is something like, in the teens, for example. All right, so let f of t be the unemployment rate for people with a full-time equivalent of t years of education. So a model for this situation is 32.66 e to the negative 0.16t. So you can see I made a computer program find this, and I found it with the E part. So you're not going to be able to do that because you don't know how with your calculator. Don't worry about it. But if I give it to you, do you know how to substitute into it, and do you know what you're looking at? So first thing I want us to find is f of 16. So let's do that. So f of 16 would be 32.66 times e to the negative 0.16 times 16. Oops, that doesn't look good. Let's put that in parentheses. At least I think it was negative 0.16. Let me double check. Yep, negative 0.16. Okay, that's fine. So I'm just going to make a computer do this, right? I'm not going to do this. All right, so clear this out. So 32.66 times second E, which is above your ln button, negative 0.16. Oh, if you have the old system, you're going to need to put parentheses around this. Sorry, I'll do that now. Parentheses negative 0.16 times 16. Don't use parentheses for that timesing. Just use a little time star. There we go. So if you're on the new system where it puts it up in the superscript, then you don't even need the parentheses. But if you're on the old system, you need a set of parentheses around that whole exponent. So you should come up with 2.52477. So if you don't, that means you typed it in your calculator wrong. So double check that exponent business. All right. So we get 2.525 or so. All right, so let me put that in. 2.525. Now, what does it mean? Because, of course, with these problems, it's not just a question of finding it, it's a question of explaining it. So 16, remember, was our independent variable. It's right here. So a person, or it's me, whoa, what am I doing? La, la, la. Sorry. People with about 16 years of education have an unemployment rate, and again, this was back when this data was from, which was, I think, the mid-2000s, but, it's okay. So people that have 16 years of education have an unemployment rate of about 2.525%. There we go. Okay, so now let's look at letter B. Now, just on a side note, I didn't have to ask it that way. I could also have asked it this way. It's the exact same thing. If I ask you for the F inverse of 0.5, that means that I'm asking you T when F of T is equal to 0.5. You with me? So I asked it this way, but keep in mind I could have asked it this way, right? Here, let me put it this way. Could have been written as there. Just a little reminder of something we learned earlier. So note. Okay. So either way that I ask it, you still have to find it, right? Okay, so you're going to have to set your equation equal to 0.5, and this is going to be the hard part. And they want us to do it by hand. Ugh. All right, so let's see. 32.66 e to the negative 0.16t is equal to 0.5. Now, you see how your variable is t. It's up here in the exponent. So the only way you're going to get it out of there is taking the log. But you can't take the log because you have all this other stuff to deal with. You have to deal with the 32 part first. You can't take the log until it's just plain e to the something. Okay, so we're going to divide both sides by 32.66. So that way we'll be able to take the log later. So 32.66 comes out. Control. There we go. This is gone. So that leaves me on the left-hand side. E to the negative 0.16t is equal to whatever 0.5 over 32.6 is. .0153. Okay, now we're going to take the ln, the natural log, of both sides. Do it to the left, got to do it to the right. Okay, so that leaves me negative 0.16t, natural log of e, times the natural log of e is equal approximately to, oh, what's that number? All right, well, I'll make my calculator find it. ln of that number is about negative 4.179. All right. So then remember that the ln of e is just 1. Right? Natural log of e is 1, so it's gone. So if a negative 0.16t is about, is about this, negative 4.179. And then you want to divide both sides by negative 0.16. There we go. All right, so I'm going to make the calculator find this. So t is about whatever that number is. So I'll take negative 4.179. I'm going to divide it by negative 0.16. It gets me about 26. 0.1, what was that? 121. Okay, so 121. There we go. Now, I know it said to do it by hand. Everybody sees the by hand. But you can also double check yourself with a calculator. Nothing's going to stop you, right? Now, if you were going to do that, how would it work? Let's see. If I go to y equals, and I clear out my old, and I don't need this equation really. I don't need to plot 1 on because I didn't put this data in, right? I'm going to type my equation, 32.66 times e, right? E to the, and if you have the old system, better do parentheses, negative 0.16x, close parentheses. Okay. This system technically doesn't need it up there in that superscript, but I'm going to put it in anyway so you guys don't get confused. And I wanted to know when this was equal to 0.5, right? Okay, so now I'm going to go to my window. I'm going to notice that my answer is about 26, so I need to go to like 30, 35, somewhere in there, right? And then we're talking about for your y values, we wanted to know when this was equal to 0.5. And our starting value is 32.66. So how about I go 0 to 35 just for the heck of it and see if that's a terrible graph. And we'll graph it. So there we go. We got the two of them. Oh, look at that. 0.5 is too low. This isn't going to work good. All right, so let's go to our window. Let's make it so our y max is much smaller. Let's make it so it's like 2. 0.5 is going to come right across right here. There it is, like that. Okay, so then we go to calculate, intersect, enter, 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 and there it goes, 26.12. Look at that. So we can back ourselves up with a calculator. Nobody's going to stop you from doing that. When they say do it by hand, it doesn't mean you can't double check yourself, right? You totally double check yourself. All right. So now what does it mean? Okay, well, time is 26, so 26 years from of education. So to have an unemployment rate, so let me put it this way. You start off with 0.5. So the unemployment rate is 0.5% for people who have about 26 years of education, which is a lot of school. Yes, tons and tons and tons of school. That is, well, that's like doctors and honestly professors sometimes, but mostly usually doctors, lawyers, that kind of thing. All right. And remember, this was because t was 26 and we started off with y. Y was given to us as 0.5, or if they'd given it to this way, y is 0.5. And our y variable was the unemployment rate. So we knew the rate was 0.5, and then we had to find for what years of education that would work. And we are all done with chapter 5. I hope you've enjoyed it. I hope logarithms haven't been too painful. And I'll see you back here for chapter 6. Factoring, foiling, all that good stuff. See you then.